Okay, we should be live. Let's go. Now it worked. I don't. I understand. Sometimes works and sometimes doesn't. It pisses me off. And also, I need to. Hmm. Let's see. Do I sound better now? I don't know. I don't think so. Well, we're gonna have to do something about the audio because I dislike it. But that's not for today. All right. The task for today, as you can see, this is X WebSocket reference for X WebSocket, and I have already pasted something to client and pasted something to main, and today we're going to try to make sense out of this. Yeah, so for anything to work, maybe let's show what works now. Mm, Here we run the server, and here we can run the client. Some website was created, and now the client is pinging the server, and that's correct. That's correct. As you can see, there is a set ping interval. It's 45 seconds. I'm not sure if it's 45 seconds here. It seems like a little a little less than 45. Maybe it's 4.5. I'm not sure. What we need to do right now um, is that we need to implement some logic for retrieval of data that is being sent to server. And from what I understand, this is a piece of code responsible for this basically. So it's on message set on message callback, which takes in a lambda. Mm, I think, and yeah, let's look at this lambda separation first. Um, okay, immediately some includes are missing. Let's fix that. And what it does, we take in WebSocket, which is a weak pointer, we take in the connection state, which is a shared pointer, and we take in that's everything we take in. Okay, and the server, which is a reference to just a normal object here. And this lambda, uh, if message type. Okay, so first it distinguishes between the message types. So it can be open. I presume that this message type message open close error ping pong fragment. I don't know what fragment means, but okay. Okay, this is basically I have a different formatting, but yeah. Um, so this is what we can respond to. Um, which probably means that we should make this into kind of a switch. I mean, I would make it into a switch at least. Um, to have everything covered, and then to kind of like dispatch the dispatch the flow from the switch to the different functions, different objects, different components. So we can see that we are printing the connection state get ID. So I guess that connection state also has ID. Um, connection. Oh well, yeah, it's connection state. As you can see, it's quite obvious what it does. It has some terminated, which is an atomic bool. It has ID. It has a callback, onset terminated callback. It has some global ID, which is again an atomic, remote IP, remote port, and socket server, which is a friend class here. Which is interesting, which means that socket server has access to those. Um, I think so, right? Does uh, does friend class have access to protected? Does friend class have access to protected? Can access the private and protected members. Yeah, yes, correct you. So then we print out the URI, and URI is basically this is URI. Wait a second. This is URI, from what I understand. Then what happens next is that we print out some headers. So there are some headers in the handshake, from what I understand. When it's an opening message, I was reading the RFC for that, and you can see that when the client opens the handshake, oh yeah, it sends out a bunch of like header fields. So I guess we will read through those. And the most important is this upgrade to WebSocket. This is the most important probably part of it, and also the stack WebSocket key, because then this is like rehashed and combined with GUID and resent to kind of a client to confirm that okay, we can start conversing. And when this is a message, so it's like a normal message because WebSocket operates in messages. TCP operates on streams, so yeah, it operates on streams. So basically, TCP can send you. Let's say you are saying "Hello World" for TCP. TCP does not have, from what I understand, any kind of requirement that it must come as "Hello World." It might come as like "Hello World," and then from what I understand, the user could reassemble it somehow. And this is TCP, right? And then WebSocket gives you the because it basically uses messages that are nicely cut into like packets. It's certain that it's basically certain that the message will be properly formatted when it enters. That's one of the key components of WebSocket. It must be like the least overhead possible. That's the main like primary reason for it. Now what happens next? That we will be just printing out if message type for an echo server, we just send back to the client whatever was received. Okay, so whatever was received, we are going to be sending this out to the client, which is pretty obvious, I guess. And now, obviously, there is something wrong with this lambda. But what exactly is wrong? Wait a second. Oh yeah, I think there should be. What's going on? What's wrong? Oh yeah, there should be. There should be that semicolon. Okay, so that's how the lambda works, and the function to set it is called set on message callback, which is a function of, I guess, lambda What do you want from us? Okay, so it wants a callback, aka, and this is wrong because. Oh shit! What? There I was thinking I'm doing something correctly. Aka function voice that takes in a const unique pointer WebSocket message. Okay. And it takes an alias, const unique pointer. So that seems correct to me. Okay, so it seems to me like we need a class for that at this point. Um, Percent ideal. Um, because we need to kind of contain the state somewhere, uh, and this just wants to be a function, and doesn't really fuck with like the option of not being a function actually. That's the hunch I'm getting. WebSocket message pointer, WebSocket message. Okay, listen. Let's maybe introduce something easier. Hmm. We'll worry about it later. That's the bare minimum here. Um, and we will extrapolate it later. Mm, so actually, this is probably correct. Actually, this might be correct. Um, okay, so it immediately is mad at us because we are not taking it to the pointer as a parameter. It is still mad at us. Const, no viable conversion. Okay. Mm, let's be smart about this. Let's just do void message callback. Takes as this, and let's just pass here Message callback. I suppose it's like okay. I have no clue what you mean right at this point. Um, const on. I'm struggling here. I probably shouldn't be struggling with that. Mm, it's learning opportunity. It's on message callback standard function void WebSocket message pointer. Oh, okay. So this is really weird because how is it supposed to even work? Because it's a const reference to a unique pointer. That's absolutely so backwards. That is so backwards. I've never seen it in my entire life. Can you do a const reference to? Isn't that like super redundant? Const reference to a unique pointer. Is it what? Why would you? Smart pointers are managing. Yeah, exactly. That's like so redundant. Why would you do a const reference to a unique pointer? Don't you know what a unique pointer? Like, what's going on here? Okay, I guess it's like. Mm, so this basically says like, take a look at this. Don't modify this. Take a look at it only, um, and don't modify this. Couldn't we just pass a const pointer to a const message? Wouldn't that be the same? I'm like super confused. That's a really confusing syntax, in my opinion, and yeah, I just don't fuck with that. I need to like, really think about it because first I'm encountering reference, post reference to a unique pointer. That sounds really redundant to me. I asked Gemini what does it think of it, but as I said, I think it's really redundant. We could just pass a const reference to the type to the value that the pointer points to, and that would be the same thing in my opinion. Unless this value is non-existent, which then I mean that might be an option, I suppose. Or like maybe some const pointer thing. Maybe that's also possible. Mm, I don't really know. Well, I don't think we have to care because we are not really interfacing more than that. So let's build it and let's see where it takes us actually. If it takes us to a comfortable place, we will kind of switch to doing something new. I mean, also related to this, but something a little different. Oh, that's lovely. That's exactly what we needed. As you can see, probably, mm, as you can probably see, those are the headers. If you compare them with those headers, it's like really similar, right? We don't have a URI because we are just using this. But if we said like new URI thingy, this will change. Look, bang. You see? New URI. Yeah. See, new URI thingy. So it's like new. Here we have the host. We have the origin, which is WS. WS stands for the port 80. Mm, then what we have here? Yeah, we have the WebSocket key, which is also here with us. WebSocket key. There is version. There is protocol. Uh, no, there isn't protocol. So yeah, actually, this works actually. This just like in design doc. Lovely. So this works, and this is awesome. I mean, it's super super. Um, what I'm afraid of is that we are not really getting this back, which I don't really understand. Why aren't we getting like? Because I thought we are sending here the function if WebSocket uh, WebSocket send message string message binary. So I don't know what's that about. That's pretty weird. But yeah, we got the communication between the client app and between the client and the server to work, which is a huge plus. And this is some step in a good direction. Now, um, what we also need to do right now is if you look at the documentation again of it, you will see that Windows. We need to use this X is in the system and un init in a net system. It is only for Windows, and you need to initialize basically you need to initialize it for Windows. And so the way we'll do this is we will write like a singleton class. I think it will be in the common library because both client and server use it. So we'll write a singleton that will store um, a boolean variable, I think, and we'll initialize it on creation, and we'll be able to query the singleton from wherever in the code, really. So yeah, so let's do this right now. Wait a second, wait a second, wait a second. It's weird that they didn't include this actually. I mean, this library this is first time seeing that. Maybe this is kind of like normal, but a const reference to a unique pointer seems unnatural to me at least. But yeah, I'm maybe just dead wrong, and this is like normal. I'm just not in the know. Model utility. So again, it's like utility. Maybe it's called it net, and let's new file um, net init manager the page. Why would you like put it here? Uh, hmm. So it's common. It's net. It's net init manager h. Actually, do you see everything clearly? I don't think so. Let me make it larger for you guys. Yeah, that looks better, I think. Mm. Anyway, hello to everybody who is watching, who is leaving quite quickly after realizing it's an actual work stream and not a reaction slop. Namespace net. Oh, net is net. Come on, net. Come on, net. Okay, let's call it net. Hmm. Hmm. Class net init manager. And now, since it's a singleton, we have public, private, we need to make the default constructor private, so we can't reconstruct it. And in private, we will also have mm, we'll also have like a bool initialized. No, or maybe I'm not. I'm not entirely convinced. Initialized. It will return boolean value, and it won't be const. And then we will also delete net init manager const. We'll also delete the move constructor and the copy, the move, and then we'll also delete the assignment operators for that because we shouldn't have those later. And those can be void or yeah, since it's not a part of the signature, it can be void and it's okay. And now we need to really think about what the initialize will do. So my first hunch was to just make it like a bool, and then this is not perfect. I need to let's actually check something. Um, or what we can do. How do you scream at us? Because I want to basically initialize it. Mm, how to do that correctly? Because if that was a normal singleton, right? That would be like initialize like an instance, and we would have static not init manager instance. Okay, maybe let's do it like that, and let's do it like that maybe, and let's make it like and okay. So this, from what I understand, this is guaranteed to be thread safe. It will basically synchronize an initialization. So um, I think I do this. But there's one important thing to do, obviously, is to actually implement the code here. And the code here, where is that? Is x init system, x init net system. And for that, the question is, do I include it? I don't. Which means that I need to basically um, grab the includes from here. Let's link those. Um, but we don't need to do this, and we just need. Actually, if we link that as public, then both client and server wouldn't have to link that because they link the common. Do you want to do that? I don't know. Maybe I should. Maybe I shouldn't. Why does it scream? Not fun. What do you mean? Okay, I think that we just need to reload this because he's like sleepy Joe. Um, net init manager .h .h sleepy Joe. Okay. Did you change your mind about not seeing that? Yeah, you changed your mind. Goodbye. And now don't forget to make this public. If you didn't make public destructor, I believe you wouldn't be able to statically allocate it because if you make the destructor private, you're not able to statically allocate it at something. And if you make a new operator private for an object, you're not able to dynamically allocate. So probably if you make both new and the destructor private, you won't be able to just create an object at all. Actually, that's like a really good question, right? I should add it like what happens if you make both new and both new and the destructor private? Like what happens to an object? Like what happens? That's a really good question, I think. Mm. Okay, so you don't need this. We don't need this actually. Um, I don't know if that's correct. I think yes. I feel like we can get away with this. And then just initialize it at the very beginning here. We just need to alter the includes. Oh, we don't. So we can just do like hashtag hash include common. Well, maybe like net. Yeah, net init manager, and then do like net init manager initialize, and this should initialize it, and at the end it should basically behave correctly with that. And the same we can do here. Mm, yeah, I mean, you don't see it, or you're just retarded. You're retarded. I see. Okay. Okay, so that's another like little performance gain on our side. I mean, gain on our side. We have created like a singleton for that. Um, and now let's show you if it actually works. Because imagine if it doesn't work. That would be mad embarrassing. Like 2.5 years of experience can't call a singleton. Holy shit. That would be absolutely terrifying. No, everything works. I mean, probably. But you don't actually see that it works because oh shit. I've noticed just now. That's not really great. Holy shit, what a shit production, isn't it? Hmm. Actually, being here is probably like optimal. Oh, I can just be like here probably. It's also pretty good spot. Okay, let's go back. Now what? So this works. So having this working is really important actually. Hmm. What we can do now is start thinking about building out the infrastructure for handle this. This is like super important. And we need a way to make. Okay, so as you can see, the WebSocket is the most important thing here because WebSocket has this funny function called send, basically sends shit. Mm, and what does the function send actually takes in? It takes in data, string of data. It takes in binary, and it takes in on progress callback, which is return binary, not. Okay, send binary, send text. Let's say that we are sending text. And if you are sending text, it's funny that it's from 7 years ago, right? So this guy in the year 2019 didn't know that a string exists. That's embarrassing. Um, actually, is it embarrassing? Probably not. Probably it's purposeful. Purposeful if he did that. Validate UTF. It's not UTF-8. Okay, so if it's not UTF-8, so the text must be in UTF-8. Then it send the message, uh, text, some kind, send message kind of text on progress callback. We send message and send message if it's connected. Return WebSocket send info false. It is okay to read and write on the same socket into different threads. Read and this makes it so that the messages aren't sent right away, and we don't need a timeout when call keeps. Okay. Since 2017, you don't have to do that. There is inference. Again, I just don't think my man knows that. So there's some kind of mutex here. Mm, then what happens next is we are okay. Send text. Mm, return send data. Send data. This is such a nice code. Actually, code is really well written. Really. Message socket send data on progress callback. Maybe we'll finally like use it somewhere. Mm, I'm really waiting for that actually. Mm, wait, I need to go back. I think I lost something along the way. Um, message. When did we turn this? text into a message. Exactly. Here's a text. And now here is already a message. So I suppose that this takes in a string into a constructor. Oh, that's a beefy ass class, man. I'm gonna lie. Yeah. Um, string decays. No, yeah, here's a string. So yeah, this takes in a string into a constructor. This takes in this constructor into a string, and then it's an English only string. So, and then we can see it sends text. Here's a message. Um, and it sends it into a frame, obviously. Can compress it. Okay, so at this point, at this point, it's pretty sure that it sent it. Oh no, it's just initialization. Never mind. And then send fragment sends it, and it calls on progress call. Large messages into the fragment. Okay, so here's fragmentation. Lovely. Well, yeah. So that's interesting that we have a client set here. That's really interesting. Mm, Okay, so I think that you've arrived at at a cool place where we can distinguish the files. Yeah, abnormal closure. Okay, and then if we do like okay, it's like this normal closure. That's super cool. That is really cool. That's really awesome. So connection state is what's responsible for that. So for doing the server and for each client with the connection state and the web server, um, I think it's kind of exposed by it. We need to store the connection state somewhere, but I don't really know where. Not yet, at least. I don't know where to store it. Um, will you please go and connection state. Okay, so it passes in the connection state here. Um, it handles it here, handle connection. It handles the upgrade. But what I'm not sure about is where hmm, it creates WebSockets for each client. What I'm not sure about is where this is managed actually. Um, disgusting, man. This guys. Um, well, where this is actually stored. This is my like main thing. Set thread name. Removing the socket class into handle upgrades. And and then we if on connection callback. On connection callback. Else if on client message callback. Else no server callback is registered. Disable automatic connection. Okay, enable pump. Um, Add this client. Okay. Mm. Okay, this is obfuscation. Now I'm convinced that short pointers, that I mean the auto keywords obfuscation. I totally glanced over this initializing something. This is obfuscation technique. Please stop using auto. Like I don't care what people say. Auto is bad in most cases. Just just use just just use the types for like holy crap. I totally glanced over it. So we are making a WebSocket here and then we are putting it into clients. But what I'm really interested in is where does the connection state originate from? Like, This is the most interesting thing, I think. Where does it originate from? It's a shared pointer, so we should be able to kind of like find some kind of STD make shared connection state somewhere. I really don't know where, but we should be able to do that. Um, mm, Apparently not here. Create connection state. We effectively don't know where does it originate from, the connection state. That worries me. Why do we have a special unique pointer? You don't need a special unique pointer for a library, man. Holy crap. What are we doing, man? Copyright 2020. This was written when this was written, man. Like this was written 6 years ago. 6 years ago. Make Unique existed. Okay, man. This is crazy because that's crazy because I don't know where this is stored. I just don't know it, and it upsets me. It really upsets me that I don't know where this is stored. Um, what I can do is I can launch WSL. We'll do something interesting once. And what we'll do, we'll grep recursively and search for this. Connect with the factory. You see? That's a pro gamer move right there. That's the pro gamer move. That's a pro gamer move. Holy shit. X web server. So I was there. I just didn't see that. X Okay, so it's X socket server. That's X, and X WebSockets this inherits, right? Yeah, this inherits after socket server. That's now this is why I could not have found that because as a matter of fact, uh, this is was okay, but we need the CPP file, right? Yeah, X. Holy shit! Can we like find it? Find it? X socket server CPP. Okay. Okay. This is used 4 times. Connect. Okay. Okay. We are really close. Connection state factory. Connection state. We are creating connection state. And then what's going on with the connection state? We'll discover it in a minute. What kind of function we are in? Socket server run. Okay. We're in a function socket server run. And what are we doing right now? For okay, so it's while true. Okay, so we created connection threads. Okay, we log something and then we push into connection threads, which is a private variable from what I understand. Yeah, which we'll discover soon. We push back, make the connection state, and the thread that will be handling connection that will move in the socket there, and that will pass in the connection state. So we'll copy the shared pointer and pass in the connection state. And connection threads is connection threads is a list. It's interesting that thing using a linked list here. A linked list of double linked list of pairs, shared connection state standard. Very interesting. That is really interesting. That is actually so interesting um, that I need to think about that more. So this guy creates. Okay, we need to go back and read more. Handle connection. Um, it's a static function, something like that. Launch the handle connection work asynchronously on its own thread. Okay, but what are we talking about really? Saying handle connection. This handle connection also. What's that? Virtual void handle connection. Oh, it's a virtual function that um, is to be overridden, I suppose. And it's overridden by WebSocket, which is not explicitly stated that it's overridden, which is um, as bad of a practice as something can be, I suppose. Um, wait, I think I lost again, actually. Um, okay, so this is abstract. Yeah, now it makes sense. So this is a virtual function. It's an abstract class, and this class is overridden by the WebSocket server, which overrides handle connection, and this looks like that. This upgrades it, and then connection state set terminated. So handle upgrade is here. Okay, so we run the socket server, and this run, I presume this is also executed as a thread somewhere. We probably never know where, but it is executed as a thread somewhere. Um, and then then we are going here to handle the connection. On the web server, we are handling the connection. We are upgrading because, and it's again compliant with this because we are sending the upgrade to WebSocket, so that's actually coming from here. And then what happens is that we set the name of the thread because this is actually happening in the thread. This is important to know. This piece of code happens on a separate thread because it's being called from here, right? We are creating a thread, and this will run on this runs on a thread. Hmm. We are checking that there is both on connection callbacks that we are setting, um, and we are actually setting it set on connection callback for server WebSocket server. So when we have created it, so I guess it runs underneath. And we are setting it, okay, and then okay, so then we are also passing in to this. Well, I understand it now. We are doing it here because set connection callback, it accepts as a parameter the connection state, and then the connection state will be a variable in this functor, in this lambda. That's why we're doing it. Oh, that makes so much sense. That makes a ton of sense. Holy, oh, my mind has just expanded. I understand it. That's really smart. I must say, I kneel to the person who coded this. That's really smart and intuitive, actually. Like you can figure it out. And then what happens? Okay, so we have these callbacks that can be actually called. Hmm, if okay, let's okay. Then disable auto reconnection. Enable disable something. We close some kind of wall guard and we insert it into okay. Then we connect socket. This looks suspiciously like another thread. Is it? No, it isn't. Some kind of connection. Mm, hello. Some kind of a connection. And then yeah, so that is kind of reasonable, I suppose. So I think as long as I'm not modifying. Hi, so I'm working um, on a server app currently. It's a server app for like a casino, you can say. It will use WebSockets to connect to a client applications and actually let me exit this WSL. Um, just- I can show you we have a really basic communication right now. We can establish it. We can run the server up here. We can run the client here. And as you can see, the client has delayed some messages, relayed some messages. We can send some more messages, as you can see, and then we can gracefully close. And we can actually connect another client, and it will be recognized as some new client with new ID. We can do the same thing. From what I understand, we can also send it concurrently. But I'm not trying it now because I believe that the library that I'm using is correct here. Right now, I'm just exploring the library that I'm using and really trying to understand what's going on under the hood of the library. Um, it says asynchronous, but I don't really mind that. From what I understand, most of the things are based on those two callbacks: set connection callback on connection callback. So when we connect, and then the library is called X WebSocket. I was trying to install Boost, but but I failed. I mean, installing Boost is um, absolutely impossible. I think. So yeah, most of it is based on this on connection callback and then on message callback. And this is quite smart because this guy is passing connection state to this callback enclosure, which means that this will be a member variable of the underlying functor, which is like really smart. And he also passes in the WebSocket that this um, that this function should be connected to, which is also quite smart because the WebSockets is like the unique way to send data to the client that is connected. So yeah, I mean it's pretty legit, I think, from what I see. I'm kind of like thinking. I don't think I will code more today, but I'm kind of like thinking about how to actually incorporate this into my design because I will need to create a lobby for the players, and I will need to create players obviously, and I think about how to actually um, make it concurrent. Uh, Hello, Terry has not visited me yet. Um, the CC files they are for C++. C++ can have CC or CPP. But they are also used for C++. Actually, I don't know because I've seen HPP like maybe once in my life, and every time I was working professionally, I only saw .h files for headers in every C++ library, even at Google. So I don't understand why like, .hpp files exist, and the .cc is just my like advanced component. We're using .cc, that's why I'm using it right now. Mm, yeah, so I think that I can start like modeling a server because it seems to be quite easy. Mm, the server itself seems to be quite easy to model. That's what I mean. But yeah, the server stuff seems to be quite easy to model. And then we'll need to make some kind of return for the um, on message callbacks. I mean, on collection callbacks. I guess that on collection callback it should also kind of like return to us something to us. Yes, I'm still at university. I'm finishing my master's degree in computer science. Nice to have you guys. But I really hate my master's degree actually, and I would like to drop out. But since it's my penultimate semester, and like I'm really finishing it, so I'm not dropping out. Yeah, yeah, exactly. Basically, Google said like finish masters and come back to us. No, no, it's good. It's good. Don't worry. It's a very good deal. I think at least. Mm. Why would you take integer as a port? Like this is what I mean. This guy, he's a capable coder, right? I mean, he coded up a whole library. But look at this. When you look at connections, right, at ports, every port is unsigned integer. Like, why would you use integer ever for a port? That makes no sense. You cannot have negative port, man. Like, why do you use integer for that? Be deliberate in like what you actually mean, and not just kind of like, oh, let's use integer for a port because I don't know that unsigned integers exist because I coded Java my whole life. God damn it. Mm. Mm. Yeah, exactly, right? Exactly. Like you can't have negative parts exactly. Like what's going on? Mm. Oh yeah, because it's servant post. No matching constructor. What do you mean no matching constructor? It's right here. But but okay, I don't care. We'll fix it later. And it should start, I guess. No, it shouldn't start. Uh, well, when you have an integer, right? When you have integer in C++, integer is basically the same as saying int 32d, right? So it's 32 bits, and its range is from minus 2 billion something to 2 billion something. It's from minus 2 to the power of 32, 31, I mean, to 2 to the power of 31 minus 1. That's the range, right? And ports, those numbers here, as you can see, they're all positive. They can't be negative. So you would use unsigned integer, right? Those integers that can be negative, and they have range from 0 to 4 billion something. Yeah, that's the stuff. Free concurrent viewers. That's the most viewers I've ever had in my entire life. Free concurrent viewers. It's really cool. Something to be proud of, I guess. And also, it probably needs us, and also it will need us to supply the callbacks, right? Mm, set connection callback. Um, it's a function that takes in weak pointer to WebSocket and short pointer to connection state. Okay, so actually probably I want to include this here. Does WebSocket does it make it public those types? Yeah, on connection callback and on message callback. Let's use those. X WebSocket server on connection callback. Connection callback and X WebSocket on message callback. And then let's set it. Set message callback and connection call client. Okay. What else we can set here? Set connection, set message, made broadcast server, made clients. Well, I guess I'm using those. I guess get clients we can do it for broadcast. I wonder if make broadcast server does because make broadcast server set on what set on client message callback connection state for each client send message. Oh, I guess so. It's like it makes the server broadcast, so every message that goes in will be sent out to everybody. Mm, that's cool, I guess. Mm. Um, okay, that's our implementation here. We'll probably refine it over the time because I believe it will require that. And actually, I would like to probably make this somehow. Let's think. Oh, well, that doesn't make sense. I'm afraid it doesn't make sense. Um, I don't know if we have to hard code this or not. I think we have to hard code this for now at least. Hmm. Yeah, for now it will be hard coded, and then we'll think about it. Hmm. Let's let's think about that though. Hmm. Okay, what's going on here? What's res? Okay, it's a result. It's pair of Boolean string. obviously we have to call use auto because we want to obfuscate the code. Like, look how much more beautiful this code would be if you just did something like that. Per bool id string result. Now all of a sudden you know what's going on in this code. But when it's auto, it's obfuscated. You have no clue what's going on. Stop using auto. It makes no sense. Especially in cases like that. Because I kind of can understand when auto is used in a case like it might make unique, but when it's used with something like that, you don't know what this function returns, like disgusting. I guess we can. Okay, so maybe this should probably have a function like start listening. We're done? Oh yeah. Okay, so it's not a constant. Return. What's going on? Hmm. Oh, there is return. What? I still don't understand what's going on. What do you mean? What do they do? Oops. Yeah, going back to this. Why doesn't this work? No much conversion from functional static as from string to standard exception. Oh yeah, because technically it doesn't take things like that as a parameter. Um, yeah, just let's just pass maybe a second. Whatever. Just I don't understand how it works. Why this works like that? A second. Standard exception takes in C strings. Why don't we take strings? Suspicious. No, a standard format returns strings. It's just that I think standard exception doesn't take the string in the parameter. I mean, technically it takes nothing in the parameter, which is I don't understand. Like, how does it work? Like, I think it takes something as a parameter. Like, exception. You can make exception pointer. Uh, invite argument, logic error, all exception, system error. Technically, it's a system error because this will most likely happen when we have something configured poorly. So now this takes a string, I think. What argument? Yeah. Const what argument? Error code. EC. Well, I guess we don't have like error code like that, so maybe not. Just standard logic error then. Yeah, it takes in a string, so we'll say logic error here. Logic error. And now we can do standard format. Um, could not connect. Now it's beautiful. And let's do what I meant to do earlier. Result. And make it explicit. Actually, there's one way to make this more interesting, which actually involves const auto, but I think that's the good use of auto because we can distribute this into result and error. And then we can do something like that, which I believe is like the best solution. And actually, this is an old way of doing this because currently in C++ we have std expected. Oops. Expected, which does exactly that. It either produces a value or an error type. So currently you could just call this function that would produce all the other like value or an error type. And then again, you could also make it like an optional error type. So there's a lot of things that can be improved on this function. So it will throw a logic error if it doesn't connect. So I think it's kind of cool. What next? And we actually need to start. Yeah, starts. And then let's wrap wait too. Okay. Wait. Is it const? Nope, it's not const. What is wait doing is probably unique lock and const variable on this lock. I mean, yeah, it's pretty obvious. What does the const variable do, actually? Oh, wait. Um, what does the condition variable do if you don't pass in the parameter, the predicate? Actually, I have like concurrency book I could use here. I know it's yeah, it's C++ concurrency in action, and actually I could probably use it to find that out. Mm. Mm. Wait, what? Yeah, it's wait with just one thingy. Yeah, the first first atomically calls lock and blocks on this. The thread will be unblocked when notify all is executed. It also may be unblocked spuriously. When unblocked calls lock, possibly blocking on the lock returns. Okay, makes sense. So it's just a barrier, something like a barrier, something like that. This code is like quite. It's weird because it was written like 6 years ago, but it uses like really archaic. I mean, not archaic, but 2011 standard, which yeah, I mean, why would you do that? Like we have 2026, and you wrote it in 2020. So you could have at least used 2017 standard, which added a bunch of things, I suppose. But this is something new. I didn't know that. You learn everything. You learn something every day. Um, Actually, I learned a lot today about the WebSocket and about this. I mean, what a fruitful day. I should be thankful for this day. Wait, okay. And server stop, right? So let's call up stop to wait, void stop. Server stop. Okay, and now we need to figure out how to deal with that. Because this is quite important, I think. So I am not really sure how to deal with that correctly. I'll be perfectly honest. Mm, what I think about is like making a private struct here. Private struct. Let's call it message holder, message message handler. That will have what we will have in this struct. We will have a WebSocket. It's a weak pointer, right? Standard weak pointer. A WebSocket. X WebSocket. I'm sorry, X WebSocket. Um, socket. It will have a standard shared pointer to X connection state, and it will have will hold the reference to the server. Actually, it probably should hold the reference to this server. Yeah, and it will have overloaded operator cooperator with that will be taking in those functions. Wait a second, what did I do? Oh no, okay, it's just one thing. Yeah, check this out. Do you know what a unique point? You know, I think you know what a unique pointer is, right? It's like a wrapper around the pointer. Yeah, condition variable is so condition variable is a concurrent programming primitive that allows you to block a thread until a certain condition is met. And basically, it's used to communicate between threads. So think about it like that. Let's say that you have a consumer thread and a producer thread. Consumer thread will block on a condition variable when kind of the storage that the consumer consumes is empty. When the producer fills the storage in, it will notify the condition variable, and then the condition variable will notify the consumer that yo, the storage is filled, you can consume. That's how condition variable is. That's the purpose here, and condition variable is like super useful. You can create semaphores using condition variables. Condition variables are used in producer consumer queues. They are like the the backbone of concurrent programming. Very important primitive, super important. Again, you can read this book. I recommend this concurrent programming in Action in C++. Although, if you really want to grasp it, um, I would propose that you would read this book first. This book is called Operating Systems, 3 Easy Pieces. It's a book about operating systems, but it also contains a whole last chapter, like actually a whole last part about concurrency. It's a really good book. I hate the operating systems, and I read this book, and I really love it. I think operating matters is about operating systems. That's saying something. Um, what was I about to do? Oh yes, I wanted to let's let's copy this code for now, but I won't be using the same code because this code is not correct, not that great, I think. So first of all, we should have a switch, I think, here for a message type because there's a bunch of message types that we can handle here. And now we can do a case for each of those types. Let's create a alias here. So it will be a little more compact, I suppose. Um, well, let's start with open, I guess. And from what I understand, from what I remember, there's only 6 of those. Right, so open, close, error, fragment, message, and what left? Oh, ping and pong. Okay, so we have those. Um, yeah, man. Thank you for staying so long. It's been a pleasure, streaming for you. Take care, man. That's so cool. That's so cool. Streaming for people. So nice. Yeah, let's finish this and I'll go sleep. Okay, I think we're gonna end it for today, but it's coming to stream anymore. I'm pretty tired. So yeah, 2 hours, 2 hours in. That's actually tremendous. I didn't think I would last like an hour. So yeah, bye for today.